Right. The first thing I want to say about the question I'm going to be dealing with is that it's a bad question. I'm going to explain at the end why it's such a terrible question. But when I say it's a bad question, I mean it's a bad exam question because there's a couple of bits that are kind of wrong about the question. However, it's not a bad teaching question. And it seems to be that something very much like this is in the question bank, so you might encounter it in your flight planning. So this is a reduced contingency fuel question. And so I'm going to assume you know the reduced contingency fuel procedure and the fact that there are potentially two calculations to make, one for destination 1 and one for destination 2. I've corrected the terminology in this. I believe in the actual exam question, they call them the destination and then a, so the correct terminology from the regulations is that you've got destination 1, which is the commercial destination, and destination 2, which is an optional refuel destination. So that's the direct quotes from the regulations. So that's the terminology I've used here. And in this case, we've got the really noticeable thing about this question, which tells you you're looking at this particular question, is this 900 kilos of additional fuel for destination 2. Now, I will tell you at the end why that's absurd, but that does affect the question quite a lot, because if it wasn't for that, then we wouldn't need to consider destination 2. So those of you who've done a lot of reduced contingency fuel questions might have noticed that as long as destination 1 is significantly further from the departure point than destination 2, and if it's at least 5%, this is usually something you can rely on. This should be something you can rely on. So if the distance to destination 1 is at least 5% greater than the distance to destination 2, then the trip fuel for destination 1 will tend to account for all the contingency for destination 2, and you can, in those questions, generally ignore destination 2. But in this question, you can't because of that 900 kilos additional fuel. So let's do the calculation for this question. And the first thing I'm going to have to note is the distance. So I'm going to note on this layer the distance from, we're going to do both calculations, the calculation for the reduced contingency fuel for destination 1 and the calculation for destination 2, which of course requires full contingency fuel. Yeah, so if you look at the regulations, the destination 2 calculation refers to the contingency fuel from the basic procedure, so you need full contingency. But first, the first calculation we're going to make will be for destination 1, which has the reduced contingency fuel. So I'm going to write down that the trip distance from departure to destination 1 via the decision point, of course, is 1,200 nautical miles. Then I'm going to write that decision point to destination 1 is 300 nautical miles. They're the two figures I'm going to need from here. Everything else is unnecessary for this first calculation, so I'm going to hide the map and we'll look at the calculation to make. So we have the usual TT cafe, really. So we've got taxi. We're asking for the sum of trip and contingency. Taxi fuel can be assumed the same or both, so we can ignore taxi fuel. So we want then trip, contingency, alternate, final reserve, and additional. Now the question does say there's no extra fuel, but you actually it says here there's no extra fuel required, so we can ignore that. Right, so the trip fuel is the full trip from the departure via the decision point to 1. That's 1,200 nautical miles. So the calculation we have to make, well, first off, we need the ground speeds actually. So if we look here, TAS is 400 knots, and from departure to destination 1, it's 400. The ground speed is going to be 450 knots because we've got a 50 knot tailwind. So ground speed 450 knots. So we take the full distance of 1,200 nautical miles divided by 450 knots, and that will give us. You'll come out with it as a decimal 2.667 hours. You can change it to hours and minutes, but it's not really necessary. It should come out as 2 hours 40 minutes if you do. We then need to multiply that by the fuel flow, which is conveniently given, fuel flow, sorry, that's 1500, not 1400, isn't it? 1500 to give us a total fuel required of 4,000 kilograms for the trip fuel. 4,000 kilograms. Yeah. So I'll just scrub this calculation because we need to recalculate now for the contingency fuel, because it's only for the last 300 nautical miles. So reduced contingency fuel, you only need contingency from the decision point to destination 1. So 300 nautical miles, we're still doing 450 knots. So 300 divided by 450 to give the time, which gives you 0.667 hours as a decimal, or 0 hours, 40 minutes. If you're going to convert it, multiplying that by 1500, that requires 1,000 kilograms. But of course, for the contingency, we only need 5% of that, multiplied by 5% or by 0.05, and we get 50 kilograms of fuel. So the contingency fuel is 50 kilograms. And the alternate fuel is given. It's given as 1,000 kilograms for this. Final reserve isn't given. We don't know. And additional fuel, we know there's 0. So we know that the total fuel required is going to be 5,050 kilograms plus final reserve fuel, which we don't know. Yeah. So that's the calculation for destination 1. And I'm going to set that aside slightly so we can later on compare it with destination 2. Obviously I've got limited space here, so I'll just set that here, and we've now got to calculate for destination 2. So I'm going to bring the map back here, and just so I can get the right space, I'm going to write the distance to destination 2 down on the bottom left. Destination 2 has a slight anomaly in that we're going at a slight change. We're going at a different ground speed for the last 70 nautical miles. So the section from the decision point to destination 2, we're going at a lower ground speed. So we need to say departure to the decision point is 900, and then decision point to destination 2 is 70 nautical miles. Yeah, and again, that's all we need from the map. So we can hide the map again. Now, let's look at our ground speeds again. We already said that our ground speed from departure to 1, which includes going via the decision point, is 450 knots. Sorry, I didn't write units here. That's bad. Nautical miles. And we can see that we only got a 20 knot tailwind from the decision point to destination 2. So our ground speed from the decision point to 2 is 420. So what I will do is I will just I'll just delete that. And the only important thing for this part of the question is that our ground speed from departure to decision point is 450 knots. Yeah, which is the same as it was for the first calculation. Obviously that section of the flight is flown exactly the same regardless of which destination. And the decision point to 2 is 420 knots. So we now need the time from departure to destination 2. So we're going to be doing the first 900 nautical miles at 450 knots. So that's going to give us a time. Probably notice that's going to be 2 hours, and then I'm going to be doing the last 70 nautical miles at 420 knots. And the time taken is going to be then 2 hours and 10 minutes. Yeah. So that will come out in decimal. If you do it all in decimals, it come out as 2.17-ish hours, but that's fine. If we then multiply 2 hours and 10 minutes by 1500, we get 3,250 kilograms of fuel. Okay, so let's draw out the total fuel for calculation 2. So destination 2, we've got trip, contingency, alternate, final reserve fuel, additional, no extra, we've already said. Okay, so trip is going to be 3,250 kilograms, 50 kilograms. Now, for destination 2 calculation, we use full contingency. As I say, the regulation actually refers to the basic procedure. So you get full contingency, 5% or potentially 3% if you had an en route alternate, none is mentioned, 5% contingency. So 5%, so 3,250 times 5% is 162.5, we'll say 163 kilograms of fuel. 163 kilograms. And our alternate fuel here is, actually, no, before I do the alternate fuel, I want to do a quick comparison. So if I just move this slightly aside and bring back my destination 1 calculation. Let's move this a bit further. Okay, there's my destination 1 calculation. And you'll see that the trip plus contingency for destination 1 was 4,050 kilos. So at this stage, trip plus contingency for destination 2 is 3,413 kilos. So at this stage, it looks like destination 1, the first calculation, is the restrictive one. And that the answer to the question, which is we want, notice the question, always read the question, trip plus contingency fuel, the sum of trip and contingency fuel, looks like it's going to be 4,050, because the answer here will be 3,413, and that's low. But we have to consider the whole calculation. And here we've got to add alternate fuel, which is 900 kilograms. Final reserve fuel, again, is unknown. And we've got to add additional fuel, which is also 900 kilograms. Okay, so if we, that's, remember I emphasize that additional fuel here of 900 kilograms is a very recognizable thing about this this question, and it's an additional fuel that only applies to the destination 2. Yeah, to I think they call it A, but destination 2. Now I add up all these fuel requirements, so 3,250 plus 163 plus 900 plus 900 gives me 5,213 kilograms. Oops. Oh, sorry, wrong color. So the sum of that is 5,213 kilograms. And so if I just make myself space again and bring back the destination 1. So this was the calculation for destination 1. Yes, that's calculation 1 in the regulation. So there's 2 paragraphs in the regulations for different calculations. So here we see the total is 5,050 plus final reserves. Here we didn't know the final reserve fuel again. It's 5,213 kilograms plus final reserve fuel. Yeah. So the actual more restrictive one is destination 2. So the answer to the question is trip plus contingency from destination 2. And the sum of those, we add those up, we get 3,413 kilograms, and that's the answer to the question. And that's all you have to do. So this does, as I said before, this is a good teaching question because it shows you the circumstances in which destination 2 is important. It's got more fuel, even though the trip plus contingency was less. And even though the contingency fuel was less for destination 1, which is obviously what we want reduced contingency fuel. The total fuel was more for destination 2, and the question asked for the trip plus contingency fuel, and that's what it wants. Okay, so that's finished with the question. So anyone who just wants to know how to do this question, you can switch off now. Thanks very much for watching the video. Right, for those that are interested in why this is such a bad question, there are a few points. Okay, so the most minor ones are things like, I believe, according to reports, again, this may not be right, it gives elevation for the destinations. Now, the reason I've put elevations of the alternates here is to say that the final reserve fuel is the same. Because if the alternates are both at the same elevation, that's the only reason elevation matters is for final reserve fuel. But of course, final reserve fuel is calculated at 1,500 feet above the elevation of the alternate, not the destination. So that may just be in the translation. That's the least of the problems. Okay, so next thing, that additional fuel. Now, this is the real problem with the question. That additional fuel is impossible. And whoever wrote this question clearly doesn't understand the regulations, because additional fuel, there are 3 reasons for additional fuel. So this is, I think, why this is actually a good learning question, because I can teach you why this is wrong. Okay, so 2 of the reasons for additional fuel require that you don't have alternate fuel. Okay, so here we have alternate fuel for both destination 1 and destination 2. So clearly those reasons are not valid. What are those reasons? Well, the first reason is if you don't have an alternate. If you select not to have an alternate under the basic procedure, you can use 15 minutes additional fuel in the hold, 15 minutes hold at 1500 feet, additional fuel instead of and not use an alternate. There are regulations. It has to be no more than 6 hours flight, has to be good weather at the destination and 2 separate runways at the destination. If you're really interested, it's in the regulations. I think it's cat.op.mpa.181 if I remember rightly. Books, go and look at that if you're interested. But you can fly without an alternate if you're going somewhere with 2 runways and the weather's good and the flight is no more than 6 hours. But in which case you have to have additional fuel. The second reason for additional fuel that means you don't have alternate fuel is the predetermined point procedure. Now that you do have a destination alternate, but the whole point of the predetermined point procedure is you don't have alternate fuel. So this clearly is neither of those. And the third reason is one that would only be used for ETOPS. So it's when you're a long way from a suitable alternate, in the event of a much higher fuel burn, either due to an engine failure or more likely due to pressurization, forcing the aircraft to descend to where it's a lot less efficient, it will burn more fuel. And at the most critical point in the flight, it must be able to divert and land with 15 minutes holding fuel in the tanks. If it can't, you have to add additional fuel. Now, where's this additional fuel coming from? Because if it's from the ETOPS restrictions, well, then either it should be for both destinations, if it's anywhere in this 900-mile segment, or if it's in the, how can it be in the last 70 nautical miles? You can't possibly be far enough from a suitable alternate in 70 nautical miles to require additional fuel. For a start, if this is a jet transport, which I believe the real question actually says is a jet transport aircraft, then you're almost certainly in the descent for the last 70 nautical miles anyway. And you've got your alternate fuel, you've got your final reserve. There's no way this additional fuel makes any sense. So I think that the person writing this question really should have written extra fuel and has no idea what additional fuel is. Yeah, so whoever wrote this question has no idea what additional fuel is, because it's impossible in this question. Okay. That's possibly not even the worst point of this question. Okay, so let's scrub that. Let's go back to whether we would even use reduced contingency fuel or not. Okay, so here we're saying that under the reduced contingency fuel procedure, we require, we require basically 5213 kilos of fuel, 5,213 kilos of fuel plus final reserves. Oops, sorry. But what if we had used the basic procedure? Well, 5% of 4,000 is 200 kilograms. So under the basic procedure, we'd have needed 4,000, another 200 contingency instead of 50. So 50 contingency is a reduced contingency fuel, and then the 1,000 alternate plus final reserve. So we'd have needed 5,200 kilograms plus final reserve fuel, which is 13 kilos less than we require on the reduced contingency fuel procedure. So this is also a question where you would never use the reduced contingency fuel fuel procedure, okay, because it actually requires more fuel. In fact, the only 2 questions I've seen reported in the feedback that require you to even consider calculation 2, i.e. the fuel calculation for the destination 2, both require at least as much fuel as the basic procedure. So you would never use reduced contingency fuel procedure in either case. But anyway, this one you certainly wouldn't, because you actually need more fuel. So those are really the reasons why this is a bad question. there are some other little wordings, like as I say, they didn't use destination 1 and destination 2 or any recognizable terminology from the regulations, which they should be doing. Then you may find in the real question that they do. They should really be using the terms. Let's clear things so I can write things out. So if you look at the regulations, they say you've got destination 1, which is the and they bracket commercial destination, and then they talk about we have a second destination 2, which is the optional refuel. That's the exact terminology, the optional refuel destination. And these are the terms they should be using. And in fact, in a lot of questions, they do use commercial destination and refuel destination. And that's what you should expect. But those are the correct terminologies. But okay, so this is not the greatest question in the world. However, I hope you learned from it. And these are questions that are causing some fuss in flight planning. So I hope that is useful to everyone. Thank you very much.